Hey math kids, today we are going to talk about inverse functions. We're in section 2DB. And so I wanted to start off with just talking about graphically what an inverse function is. So graphically, let's just start with a point actually. So 1, 2, 1. If we graph the point 2, 1, the inverse to that is if we swap the x and the y's, which would become 1, 2. So we go 1, 2, and it shows up right there. Now, 1, 2. What it is it's actually a reflection across the line y equals x. And so hopefully you can see, even with this bad drawing, that this blue dot reflected across that line and became the green dot. So if we see that with like a continuous function, we can see things like, let's do a parabola. And then if we have that line, y equals x, if we reflect everything across that, we're actually going to get a sideways. So see how I mirrored this, mirrored this, mirrored this, mirrored this. Now I'm going to mirror this piece. It actually creates a sideways parabola. Now the green one is not a function because it fails the vertical line test, but later we'll talk about how to deal with that. But for now, just this concept of flipping across that line, y equals x, that's a visual definition of what a function, or what an inverse function is. Now, the majority of your homework is going to be doing it this way. So we're given f of x. When we're doing function or inverse functions, it's best to put it back in xy notation. So change f of x, g of x, h of x, whatever you have, into a y. The next thing you want to do is actually apply the definition of an inverse, which is to switch the x and the y's. So now it's x equals 3y plus 1. This x became a y, this y became an x. Then from here on out, you just follow SADMAP and solve for y. So we will subtract 1. We get x equals 1 equals 3y. And the last step on the algebra is to divide both sides by 3. X minus 1 over 3 equals y. And then the final step is we actually want to come back to the beginning and name our function the same thing. So this is going to be x minus 1 over 3 equals f of x. But since this is not equal to this, we have to differentiate. But they are related in a very specific way. So this is an inverse of this. And so to show that, we put a little negative 1 right there. And so we say f to the negative 1 of x is equal to x minus 1 over 3. Okay, I'm going to try another one. So we'll do g of x equals 7x minus 3. So once again, we change it to xy notation. So y equals 7x minus 3. Then we swap the x and the y. So we get x equals 7y minus 3. Then we solve for y. So in this case, we add 3. Continue to solve for y. Divide by 7, divide by 7. And so we have x plus 3 over 7 equals g of x. But since it's an inverse, we say g to the negative 1 of x. And that would be our final answer on that one. Okay, we'll do one more of these linear ones. So this time we have h of x equals negative 2x plus 5. You can combine this as one step. You can swap the x and the y right now. So I can say x equals negative 2y plus 5. Do the algebra. minus 5 minus 5. X minus 5 equals negative 2y. Divide by negative 2. X minus 5 over negative 2 equals y. Now that's acceptable, but a negative on the bottom is kind of ugly. So I'm going to distribute that up and get negative x plus 5 over 2. If you wanted to swap these, you could. 5 minus x over 2. This is fine though. And that still equals y. And then we have to change it back to the h of x. So 5 minus x over 2 equals h to the negative 1 of x. And that would be our final answer. Or we could change this to an h negative 1 of x, and that could be our final answer. Or we could change this, h to the negative 1 of x, and that could be our final answer. So there's three ways that are totally acceptable. If it was in a textbook, I think this is how they would write it, because it doesn't have a negative on the bottom and it's not starting with a negative. A lot of times textbooks don't like that idea, but I don't know, I'm not super picky about it, so. Okay, now we need to talk about what happens if we start with a quadratic. So those were linear inverse functions. Now, as we saw at the beginning of the video, when we do a parabola, but then we find the inverse, it becomes a sideways parabola, which fails the vertical line test. So this is not a function. Okay. The issue with that is we want our answer to also be a function. So if you think back a few lessons, we talked about domain restrictions. So actually what we're going to do is we're going to restrict our domain to from 0 to infinity. So domain square bracket 0 to infinity. Okay, and then that's going to force our function to look like this, which passes the vertical line test. So if you start with a quadratic, which is just anything that has x squared as the leading, the highest power of x would be x squared, then we need to restrict our domain. Okay, so a problem where this would occur, so we have k of x equals 3x squared plus 2. We're going to restrict the domain and say that we only want the positive side of what's going on. So you really don't need to state that or anything. It's gonna follow the same thing. So we change it to xy notation. We swap the x and the y's. We start to solve for y. Continue to solve for y. And we would square root right here. So we have the square root of x minus 2 over 3 equals y. Now notice that I didn't put a plus or minus. I didn't put a plus or minus because we're restricting it to just the positive. So this is my inverse. Now I just need to fix the notation. And so I'm going to say k to the negative 1 of x equals the square root of x minus 2 over 3. Now I'm gonna open up calculator just to show you what these look like. So I'm going to graph the original, which was 3x squared plus 2. And then I'm also going to graph the inverse, which was the square root of x minus 2 divided by 3. And let's look at that. So we see our original parabola, and we see this, which is just the positive half. So see how we have this, and then this. If I were to draw y equals I, actually, might as well just do that, right? It's easy enough. We'll see that it's a reflection across that as well. See how just the positive half of the parabola is reflected across here? That's how we know that it's the inverse, the visual idea of the inverse. Okay? Let's go through